Deep inside that nest of sensor cabling and experimental bolt-ons is what could be the future of engine technology. When it comes to the future of cars, electrics tend to get all the love. But the internal combustion engine has been reliably moving us around the planet for over a century and isn't ready to give up just yet. Companies like Achates Power in San Diego, California, are working on radical redesigns of the internal combustion engine. It's reinventing the opposed piston engine, which could be up to 30% more fuel efficient than what we have today, as well as smaller and lighter. It could power cars directly or supplement electric motors in hybrids. The most common engine today, by far, is the four-stroke. They're incredibly refined pieces of engineering, thousands of components machined to fit and run together. One piston pulls air in and then compresses it. Then you add fuel and boom, the power stroke which drives the motion and then the exhaust. So a controlled explosion in each cylinder once every 4 strokes, thousands of times a minute. Achates upends all that and puts 2 pistons in each cylinder, which are pushed apart by the exploding fuel and gas mixture.
So what's interesting with this engine is it doesn't have any valves or any valve trains. Everything is contained basically within the cylinder assembly. So this is the cylinder, this is the opposed piston cylinder. And inside the cylinder navigate two pistons that are basically coming in opposition with each other.
This isn't a new idea, but it was mostly abandoned after about the 1940s because of problems in getting the engines to be clean and efficient. It's taken over a decade of hardware and computer control development to move past that stage.
The opposed piston two-stroke engine, while it's simple to manufacture with fewer parts and less costly, it's actually more complicated to engineer.
So in between engine runs, we can actually come in and have a little bit of a closer look. While it's not running, it's safer to be here. This is the engine. This one is a 3-cylinder variant, and those 3 cylinders run vertically here, 1, 2, 3, inside this kind of block in the middle. Everything on the top is about air going in, everything on the bottom is about the exhaust coming out, and then everything else in this room, which is getting pretty hot, is because this is a test engine, it's a development engine, so it's not in a vehicle. You have to provide everything that a vehicle would. If you look down all the labeling on these pipes here, everything from, say, oil to fuel to fresh air has to come into this room, and then the exhaust has to come out and be vented, just like it would if this was in a vehicle.
And that's the next step, a real vehicle, now that the basic science and research is nearly complete. The car is still around 4 years out, but a heavy-duty truck for the military could come sooner. Actually building engines using this layout should be fairly straightforward, because it can be done in existing factories. Even if the Trump administration doesn't have the same focus on fuel economy, global standards for vehicle emissions are going to continue to tighten, and new engines like this will help automakers meet them.